Mr. Beck does your homework. This is AP Physics, homework 3.2, question number 4. Starting to get a little more complicated here because I've got several forces acting. The magnitude of each force is 205 newtons. So I've got a pull force and I've got a push force. The pull force is at some angle. The force on the right is applied at an angle of 26 degrees, so I know that's 26 degrees, and the mass of the block is 13 kilograms. The coefficient of friction is 0.339, so it's a no, it's not frictionless. What is the magnitude of the resulting acceleration? Well, let me think about this. Free body diagram. My free body diagram says I've got a force of gravity straight down. I've got a normal force perpendicular to the surface straight up. I've got a friction force this way. I've got this push force of 205 newtons, so I'm going to put that way as a force push. And I've got this 205 newton force at 26 degrees, so I'm going to draw that one. And I'll just call that, how about F pull? Now that should be all my forces. Which of these do I know the magnitudes of? Well, I know my force of gravity, because my force of gravity is going to be the mass times the acceleration of gravity is going to be 13 kilograms times my 9.8 meters per second squared. So I know my force of gravity. My push force I know is going to be 205 newtons. That's this one here. My normal force, I don't know, because it's not going to equal gravity, because I've got this pull force that's got to be split into an x and a y. So this pull force is coming up at an angle. Let me draw that over here. That's my pull force of 205 newtons. Well, that is going to break out into a force in the x direction and a force in the y direction. Now I could make that a triangle over here with my force in the y direction, and I know that if this is theta of 26 degrees, my Fy is going to be 205 sine theta, and my Fx is going to be 205 cosine theta. So now instead of F pull, now I've got Fx this way and Fy this way. So now if I look at my up and down, I know that since this thing isn't going to be flying into the air, I know that, I'm going to write it over here, up equals down. The forces I have up are my normal force and my y direction component of this force. Downward is gravity. So I know that my normal force is actually going to be my gravity minus my force in the y direction, which is this 205 sine theta. Once I figure that out, now I've got a normal force and I've got a coefficient of friction. So now I'll have my normal force. So let's see what I figured out. I figured out this one, I figured out this one, I know this one. This one I just split into components, so I know that one. So now all that's left is my friction force. So my force of friction is going to be mu times my normal force. And they give me mu right here as 0.339. So now I also know force of friction. So now, given all those forces, I'm looking for the magnitude of the resulting acceleration. So I've got my up equals down. What about my left and my right? I don't think they're going to be the same because it's asking about the acceleration. So let me see what I've got to the right. To the right, I've got my push force, and I've got the x component here of my pull force. So it's going to be my push plus my force in the x direction. Those are to the right. To the left, I've got my force of friction. So to the left, I've got my force of friction. Now my net force is going to be the difference between how much these are pulling to the right and how much this one is pulling to the left. So it's going to be F push plus Fx minus Ff. Now once I have my net force, my acceleration is going to be my mass of 13 kilograms divided by, it's going to be my net force, which I just figured out here, divided by my mass. So acceleration is F net over m, and that will give me a resulting acceleration, and it says magnitude, so that's positive, so that's fine.